Welcome students. Today we shall be studying about significant figures, laws of combinations, accuracy and precision. So in this sequence, the first topic which we are going to study is significant figures. First of all, let us discuss what are significant figures. Every instrument has its limitation of measurement. Let us suppose there are two instruments and both of them have different limitations of measurement. One instrument may measure correct up to whole number. Therefore, in this instrument, 10th place will become uncertain. That is doubtful. While the second instrument can measure correct up to 10th place, therefore 100th place will become doubtful. Therefore, we can define significant figures as the the significant figures in a number are all the certain digits plus one doubtful digit. Following are the rules to know the number of significant figures in any number. The first rule is all non-zero digits are significant. Second rule is zeros between two non-zero digits are significant. Third rule is the zeros preceding to the first non-zero number are not significant. And the last rule is all zeros placed at the end or to the right of a number are significant provided they are on the right side of the decimal point. Significant figure and the zero coming at the end of the number is also a significant figure as it is coming after decimal and on the right side of a non-zero digit. This is very evident from the example given above. In the above example, the zeros which are coming before the non-zero non-zero figure cannot be called as significant figure, and the zero coming in between the non-zero figures can be called as a So the first law of combination is law of conservation of mass, which you can clearly see in the given chemical change that methane is undergoing combustion, and after combustion carbon dioxide and water is formed, and we can clearly see that the total mass before the chemical change or chemical reaction is equal to total mass after the chemical change or chemical reaction. Now let us talk about law of constant proportion or definite proportion. This law has been given by Proust, and it states that a pure chemical compound always contains the elements in the same proportion by mass. It hardly matters that from which source we have obtained that compound. For example, if you take water from India or you take water from any other country, or you may take water from your body, then in all the conditions the ratio of hydrogen and oxygen by mass will remain constant. It is not going to change. This we can understand with the help of the above example given. Now let us talk about law of multiple proportion. Law of multiple proportion states that whenever two elements combine to form two or more than two compounds, then the variable mass of the one element that combines with the fixed mass of another element is always in a simple whole number ratio. This is very much obvious with the help of the above example. Now, the next law is Gay-Lussac's law. This law states that whenever two or more than two gases combine to form a product, then they will do so in terms of volume also, provided the pressure and the temperature remains constant. In the above example, you can see that hydrogen gas reacts with oxygen gas to form water, and here they are reacting. Hydrogen gas is reacting with oxygen to form water, but at the same time they are reacting in terms of volume also. That is, two volumes of hydrogen reacts with one volume of oxygen to form two volumes of water. Now finally we will be discussing about Avogadro's law, which states that equal volume of all the gases contains equal number of molecules provided the pressure and temperature remains same. Now you can see in the above figure that the volume of the gas in the blue balloon is half the volume of the red balloon. Therefore, the number of molecules present in the blue balloon is also has the number of molecules, half the number of molecules present in the red and the yellow balloon, which are having the same volumes. So when the volume becomes half, then the number of molecules also become half. This is very clear from the diagram. Now let us define accuracy and precision. Accuracy is a measure of the difference between the experimental value or the mean value of a set of measurements and the true value. Mean to say, it is the difference between experimental value and true value. As much there is a difference between the experimental value and the true value, as much less will be accuracy, and as much the experimental value and the true value are close to each other, more accuracy will be there in the measurement. Now, regarding the precision refers to how closely two or more measurements of the same quantity agree with one another. For example, in the above figure you can see, in the first case, the readings taken by the student, which are represented with the help of a cross sign, are not very close to each other, and secondly they are away from the true reading, which is represented by the center. Therefore neither the first reading has a accuracy nor precision. In the second case, you can see the readings are very close to the true reading, but the readings are far away from each other. Therefore the reading is accurate but has low precision. In the third case, all the readings are very close to each other but away from the center, therefore having the center represents the true value. While we can see that with the help of a cross sign, the readings taken by a student has been symbolized. In the first case, the readings, they are far apart from each other, that is they are less precise, and also they are away from the accurate reading. Therefore it is neither therefore having precision, that is the readings are very precise but away from the center, therefore they don't have accuracy. In the last case, you can see all the readings are very close to each other and they are very near to the true reading, therefore such a reading will be called as precise as well as it will have accuracy.